Hello, welcome to today's video. So I've got the UMO C445 controller here where I've removed, we're down to just the one IGBT brick, half bridge. And I've kind of just threw everything on here so you can see the, if you watched the last video, that's the gate driver. And that's about where it's going to be situated. So I ended up with the middle IGBT. I took out the one that was over here and the one that's on this side, because it was kind of worked out better with it being in the middle. So I've got the inductor here. I have a Prius. We got the contactor. We have DMOC adapter, which has been repurposed to become a PWM power supply, essentially a power converter. And the output side, so essentially everything from here over is low voltage. This will all be the 48 volt side, and then everything from, well, I guess technically including the inductor, about halfway here, will all be the high voltage side. So there's a gap here because this will have, I got to cut these bus bars that went across. Those are going to get cut up to support my input capacitor here, and then next to that will be the high voltage output capacitor here. And yeah, so that's pretty much what's going on there. We've got the plate here, and this arrangement I came up with because if I put the plate on here, you can see the two that come in will be power and ground, and then we've got holes over here for the output side. But essentially we'll have ground comes in. Well, if you look at the schematic here, we only really have, I mean, the high voltage wiring on this is pretty simple. So we're going to have essentially ground will come in through here, and it'll just go over to the emitter, and then that'll be connected to the capacitors, and then it'll come out to the output. Whereas the 48 volts will come in, it'll go to this contactor, first traveling through one of these current sensors. I'm going to unsolder these because we need one on the input and one on the output. And that'll come into this contactor, to the plus side of the contactor. Minus side will come over to the inductor. It'll go through the inductor, and then that'll come down to this point here, which is the emitter and collector. Emitter 1, collector 2. This is the common point between them. And then, yeah, let me think about that. Is that right? Yeah, that comes into there. And then coming off of this side here will be the high voltage. So this will be then 500 volts. That's why I'm going to isolate everything over here. Whoa. Try not to break it by knocking it over. Oh, I had it like precariously centered there. Oh, okay, we got it back. So 500 volts coming out of this terminal will then come across to this, which is backwards because technically this is the positive side, so I'll flip that around. Positive input, and then coming out of here will be, it'll go through that current sensor again and then out of the thing. So we'll have the high voltage output on this side, low voltage input on this side. And you know, these are labeled plus and minus, but it doesn't really matter because we're going to be doing bidirectional anyway. So, but we want to set it up for the maximum current flow, which would be typically this direction, because we're going to be pulling 48 and boost converting up to higher voltage more often, because that's going to require more current, whereas buck converting down, when we're like hooking up a batteries can only put out about 20 amps or so. So that would be 20 amps at and then it'll go back through the other way, but not too worried about that. Then we got to fabricate some mounting brackets for this right angle. I've got some leftover little right angle brackety type pieces here that we can cut up to do that. And this already has brackets on it, right angle bracket, so you just got to drill and tap some holes there. And yeah, I think that's it. That's kind of what the high voltage layout for this is going to look like. And again, we're keeping all the low voltage stuff on one side and all the high voltage stuff on the other side. And a lot of there's going to be some other power resistor that goes across here, and with the IGBT to turn it on for pre-charging. And the same on this side, we'll have a power resistor that goes across there. I actually have them over here in my box of parts, but there's one of them. And there you go. So here's a couple more power resistors. So these ones are 50 ohm. 50 ohm, if it'll ever focus. There you go. 50 ohm, 50 watt resistors for just the pre-charge. I don't remember what this one is. I think it's a higher. It's lost its little label. I have to open it up, but anyways, those are the power resistors for pre-charging, and we'll have those hooked up in here too. They'll just be mounted down here, so wherever there's some room, there'll just be little wires that go up to them, and just with some ring terminals. So that'll be pretty simple, and the control circuit will get back over to this guy to control them. We'll have that hooked up as well, and yeah, I think it should be good. Anyways, yeah, that's what's going on with this. Yep, quick video. Well, kind of quick. Anyways, thanks for watching.